let's talk a little bit about the spectrum. In other words, the range of frequencies that we have available to us in the electromagnetic wave spectrum. So first of all, we are familiar with visible light. This is a certain frequency. In fact, it's a very small range of frequencies that we're actually able to see. But if we get a little higher than that, we can no longer see it in the ultraviolet range over here. So this is the visible spectrum, ultraviolet spectrum, and there are some creatures, by the way, who can actually see ultraviolet. So for example, the bee can see ultraviolet radiation. We have no idea what that color looks like. Our eyes are just not equipped to see it. So it'd be interesting to see what that would look like if we were a bee. But anyway, this is used occasionally for communication, but not often. And then of course we have X-rays. At this point, we can actually travel these things through the body, and that's why we can use them for imaging. As you're aware of an X-ray that can see the difference between the density of the bone and the density of flesh around it, because these can actually travel through the body. As they get up here in the higher wavelengths, the gamma rays, these also travel through the body, but they are they're so small at this point. Those wavelengths are so small at these high frequencies that they can interfere with our DNA and cause cancer and so forth. Then as we get down below the visible spectrum, we move into the infrared radiation. And by the way, we can use everything from around visible light on down, maybe a little bit into the ultraviolet, for communication. We haven't begun to try to communicate using these up here. But remember, the higher you go, the faster it peters out. And so it's hard to use it for very great distance for communication. These down here we can use for greater distance, although we can't fit as much data in them. So in the infrared range, where the pit viper and so on can see, we don't know what that color would look like because our eyes are not equipped to see it. But we do use infrared in communication. For example, the remote control on your TV can send information to say, yeah, increase the volume, decrease the volume, change the channel, and so on. Down here in the microwave range, by the way, you can see that microwaves are a subset of radio waves here. FM radio and TV operate in the microwave range. AM radio operates down here in the radio wave range. But also you can see that the common Wi-Fi and Bluetooth and all of that actually operates up here squarely in the microwave range, and that's why microwave ovens can often interfere with those communication devices. 900 megahertz was often used in the early cordless phones. 2.4 and 5.0 gigahertz are used by Wi-Fi and Bluetooth and others. We're now clearing some space. The FCC is clearing some space in the 6 gigahertz range for communications. These are unlicensed spaces, by the way, 900, 2.4, and 500. And that's why we use them, because we don't have to have FCC licenses to use those bands. But we are now clearing some space in the 6 gigahertz for 5G cell phones and so forth. And by the way, when you hear all about the health hazards of 5G, take a look at where it is. It's really, because it's high frequency. Well, no, it's really not. In fact, we're bombarded with visible light all the time, and that's not killing us, other than some ultraviolet and X-ray. When we get up from the sun, that can cause some skin cancer. But visible light itself is not killing us and or harming us in any way. How is it that these down here are going to? And in relation to 5 gigahertz, it's nothing. And so I get off my soapbox now. So you can see that we use microwaves primarily for our digital communications, although we use some infrared. So that's the spectrum. Now, we call this all light. These are all photons. Even though we think of light in this range, I can think of all of these as light if I want to, from a physics standpoint anyway.